For today class, we will continue our lecture with chapter 5, aromatic hydrocarbon, which is we will focusing on the subtopic reaction and mechanism or covering the electrophilic aromatic substitution. So I will show you the reaction. However, for the mechanism, I will share some of the YouTube videos. For the reaction for aromatic compound, it involves 1, 2, 3, and 4 for reaction, which is reaction of, we focusing on benzene. Okay, reaction of benzene. So in your syllabus, we will focusing on halogenation. We will focusing on nitration, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation. Okay, so let's take a look what is a halogenation reaction. Normally the reagent and condition, normally we can use Br2, the present of FeBr3, or Cl2 in the present of FeCl3. Both these chemicals will act as a catalyst. It will increase the rate of reaction. And for the nitration, the reagent and condition used is nitric acid in the presence of sulfuric acid. And then for the Friedel-Crafts alkylation, it involves the alkyl group, which is here, reagent and condition. So alkyl group is R, X, alkyl halide in the presence of Al, AlX3. So R is representing alkyl group, so it can be CH3 or CH2, CH3, or CH2, CH2, CH3, and so forth. And for X is representing halogen group, either Br or Cl. And for the Fieldcraft acylation, so it involves acyl group or R C double bond O X involved, we call as here is acyl, highlight, in the presence of also AlX3. Okay. And finally, for the sulfonation involve the reagent and condition that use sulfur trioxide in the presence of sulfuric acid. Okay. So basically 1, 2, 3, 4 and 5. 5 reaction of benzene. Okay. Then I will go through one by one what is halogenation, what is nitration, sulfonation, and Fieldcraft acylation and acylation. Okay, for example, here you have a benzene ring. So you have a benzene ring react with Br2 and the presence of FeBr3. So basically we have here one hydrogen. What happened here? Hydrogen here is substitute with Br. So that's why we call electrophilic aromatic substitution. Why we call as aromatic? Because it involves benzene ring. Why we call as a substitution? Because this hydrogen is substitute with Br. Why it state here electrophilic? Because the character of the Br is electrophilic character, or it is an electrophile. So hydrogen here is substitute with bromine that is electrophile involved in aromatic compound. So the reaction given was electrophilic aromatic substitution. Okay. Another example. So we have here again hydrogen here is substitute or react with Cl2 in the presence of FeCl3. So what happened here? This hydrogen here is substitute with Cl because here you use Cl. So it substitute hydrogen with Cl. Okay, this is halogenation. So what is the nitration reaction? So the nitration involve, so you have here benzene ring, you have here his hydrogen, react with HNO2 O3, or we call as a nitric acid in the presence of sulfuric acid. So what happened here, this hydrogen will be substituted with nitro group. So it will become nitrobenzene. So this reaction is called as a nitration. Okay. Then sulfonation. Okay, what is a sulfonation? So you have an example here, benzene ring. Have here hydrogen. React with sulfur trioxide in the presence of sulfuric acid. So this hydrogen here is substituted with SO3H, or it will produce benzene sulfonic acid. And Friedecraft acylation. So you have a benzene ring here. So what happened here, this hydrogen, so react with, example we have R group, which is methyl CH3Cl, and the catalyst that we use is aluminium trichloride, because when here is chlorine, here also chlorine. So what happened here, this hydrogen is substituted with CH3, and this is the byproduct HCl plus AlCl3. So the major product would be this one, or we call as toluene. You still remember the priority group, when benzene combine with other substituent, the name will change to other name. For example, toluene, anisole, benzene sulfonic acid, benzaldehyde, phenol. Okay, you need to memorize back or to recap back. And then finally for Friedecraft acylation. So you have benzene here. So this benzene will react with R. So you have here is CH3, C double bond O, Cl in the presence of AlCl3. So it will means that this hydrogen is substituted with C double bond O, CH3. So this hydrogen here is substituted with acyl group. Okay. Basically, this is the reaction of benzene. So you need to understand the reaction, and finally you need to memorize it. Then what happen if you start the reaction with the benzene that has a substituent on it? Because here this benzene just has hydrogen. What happen if this hydrogen we substitute with other compound? For example, you have Cl here, or you substitute with nitro group. Okay, what happened here? So we need to take a look of the we call as the effect of substituent on the reactivity of the benzene ring. So this substituent will give the effect in terms of reactivity and orientation. So, okay, I will give an example. Okay, this is a benzene. So, normally as we know, this benzene only attached to one hydrogen for each carbon. So what happened when we try to substitute here this hydrogen with let's say we substitute with Cl, and another one we substitute this hydrogen with with nitro group, let's say. So what is the difference between A and B? What is the major difference between A and B? The major difference between compound A and B is the substituent attached to the benzene ring. So, what is the characteristic for both substituent, Cl and nitro group? So, Cl is categorized as activating group, while nitro group is categorized as deactivating group. What does it mean by activating group? Activating group, what is the function of the activating group? Activating group will donate the electron to the benzene ring stabilize. When it donate the electron, it will stabilize the carbocation intermediate hence the reaction will here tak cukup, reaction will increase. And for the nitro group, So the characteristic is it will withdraw the electrons from the benzene ring and destabilize carbocation intermediate and decrease rate of reaction. Okay, when the question asks you to define or to distinguish between activating group and deactivating group, you should answer like this. Donate the electron to the benzene ring, stabilize the carbocation intermediate, and increase the rate of reaction. Here is rate reaction will increase. Whereas for deactivating group, it will withdraw the electron from the benzene ring, destabilize carbocation intermediate, and decrease the rate of reaction. Okay. And here is in term of number 1 is effect to the reactivity. Means that the effect of substituent to the reactivity of the benzene ring. And another effect is number 2 is effect to orientation. So, how? So, you have a benzene ring here and another one here. Okay, one benzene ring attached to OH. One benzene ring attached to COOH. So what is the behavior for OH and COOH? OH, the behavior or the characteristic of the OH is activating group. Here is carboxylic group. So the characteristic is deactivating group. And at the same time, OH will act as auto para director. While carboxylic acid will act as a meta director. What is auto para director and what is meta director? So let's say we react with Cl2 and in the presence of FeCl3. So what happened here? This OH will direct the location of the electrophile, which is in this case the electrophile is referring to Cl. So it will direct the orientation, or we call as the location of Cl to location ortho, and another one to the location para. So that's why it is called as auto para director, because it direct the orientation or the location of Cl to the orientation of ortho and para. Ortho is 1, 2. Para is 1, 4. Why we call as 1, 2 and 1, 4? Because here is 1 and 2. 1 and 4. And how about a meta director? So for the meta director, when you have Cl2 in the presence of FeCl3, so what happened here? So it will direct the location of the Cl into 1, 2, 3 meta director. Okay. That's it for today. So we can do, maybe after this we can do a few questions in tutorial.